Okay, so here's a few problems from the homework assignment that you have for the weekend. I'm not going to do all of them, but I'm going to do a fair amount of them. And that way, if you still didn't quite get it from the video, because it's a tough section, you at least have some kind of something here to help you extra. So first of all, number 3 is to find the geometric mean. Now the formula for geometric mean is a over x equals x over b. Okay, where x is the geometric mean and a and b are the two values. So in our case, we have 4 and 7. So this would be 4 over x equals x over 7. And then to solve a proportion, just cross multiply. And then take your square root, square root of 28. Now another way that I showed as well, or at least I'll talk about in classes, you could also think about solving this ahead of time, and you get x squared equals ab when you cross multiply. Take the square root. So there's a shortcut for the geometric mean, the square root of the two numbers. So this formula is fine to memorize. This one's also fine, but it tends to be that people tend to use this one because for some reason it's easier to memorize. Now the thing that is new is we do go back to algebra 1, so we do have to simplify this radical of the square root of 28. So the easiest way to do that is that square roots have squares, which means pairs of factors. So 28 is 4 times 7, and then 4 is 2 times 2. And I always have a habit of marking out the non-prime factors, the composite factors. So 2 and 2, hey, there's a pair of 2's. That means there's 1, 2 I get to bring out. And then there's a 7 left over that doesn't have a pair, so root 7. So the geometric mean of 4 and 7 is 2 root 7. Okay. Now the next example I want to go over is number 8. Okay. Now number 8, you are just supposed to find the three similar triangles and write them out. So the trick I go over for doing this, because some of you will be really good at seeing this, but some of you won't be, is to just draw, first of all, mark the two acute angles, one with a single mark, one with a double mark, and then draw 3 triangles in the exact same orientation, just like this. And I make one big, make one medium, and then I make one small. Okay. Now the big one is the overall one. So it's M, N, L, because the right angle's in the bottom right hand corner. So it's M, N, L. Okay. The medium sized one, the middle one, okay, is, sorry, I just hit my thing there. The medium sized one is going to be the one that's the middle sized one, which is this guy here. And he has his right angle at P. He has his double mark at L, and his leftover one that I haven't marked at all is what point N. And then the small guy, he has his single mark at M. He has his right angle also at P, and his leftover one is also N. And so the reason I like to do it this way is that I can look at the 3 triangles and just line them up. Triangle MNL is similar to triangle, I went MNL, so that'll be NPL, which is similar to triangle MPN. Okay, there we go. Okay, so that was number 8. Yeah, all simplified out in the 3 different triangles similar. Now, the next part is problem number 11. Okay. Now 11 and 12 and 13 and 14, you could do this. And I showed you in the video writing these out and then labeling the sides and then just setting up the proportions. But the point is not to do this every time because this is tedious. It takes a lot of time to do. The real point is that there's a shortcut. Okay, and what the shortcut is that there are 2 types of geometric means. There's the geometric mean that involves the altitude, okay, which we don't know Z in this one, so that's one we're going to solve for first actually. So Z is the geometric mean of the 2 parts of the hypotenuse. That's the shortcut. So again, you could draw it out and see that relationship, or just know the altitude of a right triangle drawn inside of it is the geometric mean of the 2 parts it creates of the hypotenuse. So the shortcut is then it's just going to be simply 3 times 9, square root of that, which is square root of 27. And then you break 27 down, and that gives you a pair of 3's with the 3 left over inside. So there's Z, 3 root 3. Okay. Now, X then and Y, These are the ones that are a little harder. If you're a leg of the big triangle, you are the geometric mean of the little part next to you, which is 3, and the whole hypotenuse, which in this case is 12. So x is the geometric mean of 3 times 12, which actually works out nicely for us because it's the square root of 36, which is 6. And then y is the same thing. The other leg, the other big leg, y, is the geometric mean of the part touching it, which is 9, and the whole hypotenuse, which is 12, which gives us a square root then of 108. And unfortunately, 108 is not a square root, so I'm going to have to break this down. So I can divide by 2 and 54, 2 and 27, 3 and 9, 3 and 3. Okay. So you have a pair of 2s, you have a pair of 3s, and then you have this 1 3 left over. So this becomes then 6 root 3. There we go. There's number 11. Number 12 is the exact same problem, really, so I'm going to leave 12 for you to try, but it really is the exact same setup, just different numbers. So then we'll jump to number 13, which actually is also the same problem. The one that's different finally is number 14. So actually, yeah, 13, 12, and 11 are all the same. It's just that you're looking for the two big legs and then the altitude. Now, number 14 then, this one's a little different. Well, it starts off a little different at least. A little differently, I should say. This one, I'm looking for part of the hypotenuse, big leg, other big leg. Okay. Now the problem with this is I don't know this part because z, the big leg, is the geometric mean of the part of the hypotenuse that cuts up next to it. So x times the whole hypotenuse. Well, the whole hypotenuse is x plus 2. So that's x times, I have to know what the heck x is to do that. So basically what that's implying to me is find x first, and once you know x, you're good. Same thing for y. If I tried to find y is the geometric mean of the part next to it, which is 2 times the whole hypotenuse, which is x plus 2. So again, I'm still stuck in the same problem. Z and y both have to have x solved for. So this is where you have to realize that, oh, I know the altitude. If I know the altitude, it's the geometric mean of the two parts of the major hypotenuse. So x is not the altitude this time, 5 is. So 5 is the geometric mean of x and 2. So I have 5 equals the square root of 2x. So now to solve for x, square both of them. Divide by 2. So that gives me then 12.5 equals x. Okay. So now then z is the square root of 12.5 times 12.5 plus 2, so 14.5. Now in this case we're just going to have to get a decimal for that because it's not going to work out nicely. And this one will be the square root of 2 times 12.5.2, which is 14.5, which is the square root of 29. That's the best that guy is. So I'll get out my calculator real quick. There we go. So the square root of 12.5 times 14.5, which is, let's see what that is. That's 181.25. So the square root, 13.46. So yeah, approximately 13.5. Now, the only reason I didn't do this as a radical is because I'd have the square root of 181.25, which I guess I could leave it like that, but that's not going to break down any, so we'll just leave it that way. Okay, so hopefully that helped. Again, it's a bit of a rough section. We're going to come in on Monday and still talk some more about it, but I wanted you to have a chance to do some practice problems on your own and having a little bit of video there to help you out with it too. Thanks.